In this video, I'm going to go through some examples of diagonalization. So an n by n square matrix A is diagonalizable if it has n linearly independent eigenvectors, and if we put those eigenvectors as the columns of a matrix P, then we can calculate the inverse of P, because the columns of the matrix are all linearly independent. And if we multiply that matrix inverse by A and then by P, we end up with a diagonal matrix with the eigenvalues of A along the main diagonal. So let's see a couple of examples of this. Let's start with a 2 by 2 example, and we looked at this example in the video on calculating eigenvalues and eigenvectors, and we found that the first eigenvalue lambda 1 equals 1 has an associated eigenvector p1 equal 1 1, and the second eigenvalue lambda 2 equals 2 has an associated eigenvector p2 equals 3 4. So if we put those two eigenvectors together in a matrix which we'll call P, so 1 1 and then 3 4, if we calculate P inverse, which in this case is going to be 4 minus 3 and then minus 1 1, if we next put P inverse multiplied by A multiplied by P, then we end up with a diagonal matrix with the eigenvalues along the main diagonal. A diagonal matrix has 0 entries off of the main diagonal, so in this case a 0 here and a 0 here. So let's go through a second example. Let's go through a 3 by 3 example. So again, we looked at this example matrix A in the video on eigenvalues and eigenvectors, and we found that the first eigenvalue was lambda 1 equals minus 1 with an eigenvector of minus 4 5 2. The second eigenvalue was lambda 2 equals 0 with an eigenvector of minus 1 1, and the third eigenvalue was lambda 3 equals 2 with an eigenvector of 1 1 1. So let's put those three eigenvectors together in a matrix which we'll call P. So we've got minus 4 5 and 2, and then we've got minus 1 1 and 1, and then we've got 1 1 1. P inverse in this case is 0 1/3 minus 1/3 minus a half minus 1 3/2, and then final row, third row, 1/2 1/3 1/6. And then if we calculate P inverse times A times P, what we end up with is minus 1 0 0 0 0 0 and 0 0 2. So again, it's a diagonal matrix where we've got zeros off the main diagonal here, here and here, and here, here and here, and the eigenvalues minus 1 0 and 2 are along the diagonal. So that's a few examples of diagonalizing square matrices.